This is going on page 51 when we're done. Okay, so we have a triangle sum theorem. So I want you to think for a second. I want to know, think without speaking, what is the difference between a theorem and a postulate? Mariah. Can you tell me at least what a postulate is? It's what? Not that it has many definitions, really. You can look back at your notes if you need to. So we're doing right after those points, lines, and planes stuff. It's yellow, I believe. Good. It is a statement that is accepted as true without proof, right? We just go, oh, yeah, that's it, but I can't mathematically prove it to you, right? So then, Mariah, what do you think that means a theorem is? It has proof. A theorem is something I can prove, right? So, and sometimes we use postulates to help us prove theorems, but this is a theorem, right? Triangle sum theorem. And it says the sum of the measures of the angle of a triangle is, and I want to know what that is from Nia. What's the sum of the measures of the angles of a triangle? You're going to have to talk louder than that. 180 what? Feet? Degrees? Do you agree with that? Yes. Okay. The sum of the measures of the, and this should say, not just the angles, but the interior angles of a triangle is 180 degrees. So remember, that is why you have been allowed all these years to be able to find missing angles of a triangle, because you have this theorem. Although you weren't really following the theorem most of the time, because if I gave you two angles and asked for this one, you'd say, well, I just add those two together and subtract from 180, right? Is there a subtraction theorem here? No. What does sum mean? Addition. So the theorem says the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. You need to think and write algebraically. Okay, that is where some of y'all are getting stumped on things, because you think you can figure it out in this backwards way in your mind, which sometimes you can, but that doesn't always work so well when we throw a bunch of expressions in there. Okay, plus there's no logic behind that for anybody to follow. And for AP stuff, you've got to have that where anybody could look at your paper and completely follow your train of thought, even if you have bad handwriting. Okay, it's not about the handwriting being bad, it's about things being organized. You can have organized work with crazy bad handwriting, because at this point, we can't fix your handwriting. I know that. All right, so then we have corollaries. So all a corollary is, this is our first corollary, a corollary is just a theorem whose proof follows directly from another theorem. It's kind of like a sub-theorem. Do we really have to be told this? No, because we should be able to figure it out from the other theorem. Okay, so this says the acute angles of a right triangle are blank. So I want to know, first of all, what is an acute angle? Adrian. Good. Angle that's less than 90 and greater than 0, right? So the acute angles of a right triangle. Do all right triangles have acute angles? Yes. How many acute angles would every right triangle ever have? 2. It's impossible for these two angles to be anything other than acute. Do we agree with that? Right. It totally makes sense, right? So let's think about that. We have a right triangle. Does that mean that this is 45 and this is 45? No. Could it be? Yeah, but that doesn't happen every time, right? So I want you to think, what would be true about the two acute angles together every single time in a right triangle? What do you think would have to be true, Jenny? The question is, what do you think goes here? The acute angles of a right triangle are blank. What would have to be true about the acute angles as a pair in a right triangle every single time? Okay, huh? Do you want to try? Go ahead. Complementary? Why do they have to? 90. Complementary. Very good. Good job, Ms. Ramirez. All right, so, Ginny, the acute angles of a right triangle are what? Complementary. Did you understand Ms. Ramirez's explanation? Yes, right? It's because the sum of the angles is 180. And in a right triangle, one of the angles is always going to be replaced with 90. And so that when you just look at the sum of the other two, they're going to have to be 90. So angles D and E are acute angles. They have to be, right? Because otherwise we'd have more than 180. And the measure of angle D plus the measure of angle E equals 90 degrees. No, she's trying to do walkthroughs through all the math teachers, and so she just walks down the hall and just stays a few minutes as often. Oh, she's our assistant principal. Yeah, although she hasn't written anything down, but yeah. So she just comes and hangs out. She's new to us. She's new to the school, so she's also just trying to get a feel for what's going on in the classrooms, that sort of thing. So I also told her how horrible y'all were, so she comes in every time. I'm just kidding. So third period's bad. You gotta come check it. Yes, sir. Yeah, she gets mad at that, right? All right, so the measure of each angle in an equiangular triangle is, what is it? What does it have to be? We already talked about this. 60, right? And this comes from the triangle sum theorem as well, because I can say a measure of angle A plus a measure of angle B plus a measure of angle C equals 180, but then I can substitute things since they're all congruent, right? Basically, I could say the measure of angle A 3 times. So 3 times the measure of angle A equals 180, so they each have to be 60. Okay, good. So we should know that for sure. And so these are all equal to each other, which is equal to 60 degrees. Okay. So we're going to find the measure of each angle over here. And just because they're numbered 1, 2, and 3 doesn't mean we have to necessarily find them in that order, right? So which one do you want to find first? Which one? What? Well, Aiden was answering, and I don't know if y'all like peer pressure and he changed his mind, but oh, you went, okay. I thought you were changing your mind. They just wouldn't let you talk, huh? Okay, we're going to find angle 1 first because that's what Aiden said. Then we'll find 2. Does it really matter? No. No. Okay. Do we have enough information to find 1 right now? Yes. Do we have enough information to find 2? Do we have enough information to find 3 right now? No. We really don't. Well, we do. You just don't know how to yet, but it's okay. All right, so we're going to find the measure of angle 1. All right, so Aiden, tell me what you know about angle 1. Yeah, exactly. It's a linear pair. And so we know a linear pair is what? Supplementary, right? So the measure of angle 1 plus 57 has to equal 180. We know we get to set that up because if they are a linear pair, then they are supplementary. So now, what's 180 minus 57? What is it? 123. Y'all agree with that? I'm kind of quiet. Nobody wants to subtract today. 123. Oh, I just put measuring 1. So I'm going to label this on here, 123. Okay, so now we'll do angle 2, because some of y'all wanted to do angle 2 first. Doesn't really matter, right? All right, so I want to know, what do I set up? Oh, Aiden again. You complained the other day you never get to talk. Now you get to tell me. What I set up here? Good. All right, so measure of angle 2 plus 57 plus 71 equals 180. And we know that's true because, now, some of our theorems have names, and sometimes we get to use the names. Most of the time we don't. But for this one, it's a lot easier just to go ahead and do it. And we're going to say that's just the triangle sum theorem. That's how we know we get to do that. You can abbreviate theorem THM. So triangle sum theorem, that's a lot shorter than actually trying to abbreviate the theorem itself. All right, so then I add these two together. So the measure of angle 2 plus, what's 57 plus 71? 128 equals 180. So the measure of angle 2 equals 52 degrees. Angles have degrees on them, by the way. That's something else y'all got taken off for on your quiz. 52 degrees. All right, so now angle 3. Do I have more than one way I could find angle 3? Yes. Could I use the big triangle? Triangle JKM? I could. Is there an easier way? Yes. To use JKL, right? It'd just be a little bit easier. I could do that. So those 3 angles also have to add to give me 180, right? So the measure of angle 3 plus 123 plus 28 equals 180. That is the triangle sum theorem. So measure of angle 3 plus, what? 151 equals 180. So the measure of angle 3 equals 29 degrees. Now, is the fact that there's 180 degrees in a triangle new to you? No. Is the fact that there's a theorem that tells you that new to you? Yeah, probably you didn't really know that that was, but remember, there's a rule for everything. So the only new part to this is that you have to actually set up an equation, because everything you do, you have to think algebraically. Okay, if you cannot think algebraically, you're going to do nothing but struggle. Okay, so that's something that I have to train you to do. All these things that you can do backwards and upside down in your head, you have to learn how to take those backwards, upside down things and put them into equations so that you can go logically through things. Okay, all right. And find the measure of each angle here. So, let's see. Could I start with angle 1? I could. We might as well just start with angle 1. Now, is there more than one way to start with angle 1? Yes. So I want to know what I should write down from Eileen. What little equation could I make? So like literally, what do I write down? Okay, so measure of angle 1 plus 52 degrees plus 90 equals 180. Does that make sense? Y'all agree with that? Okay, I want a different way to do it than that. There's an easier way to do it than that. Kishara, what do you think? We talked about some stuff on the front that might help you out. What kind of triangle does angle 1 live in, Kishara? Okay, it lives in a what? A right angle? As to what kind of triangle it lives in. I think you're on the right track, but you didn't answer with the name of a triangle. What kind of triangle does angle 1 live in? Is it acute, obtuse, right, isosceles, equilateral, equiangular? It's a right triangle. Okay, so look on the front there. What do we have about a right triangle that might help us out here? Okay, so what could I write down besides adding them all up and setting them equal to 180? Plus 52 equals what? Equals 90 degrees. Okay, good. Right? Why use a whole bunch of extra numbers when you don't need it? That's a right triangle. That's a much, much simpler way to do this. So we know here that's because the acute angles of a right triangle are complementary. That means then that the measure of angle 1 is not 48, it is 38. 48 is a very common wrong answer there. This is 38 degrees. What? acute angles of a right triangle, thank you, I did what she did, are complementary. Not of a right angle, that didn't make any sense. Of a, that's not art, it's of a right triangle are complementary. All right, let's see, can we jump to number 2, angle 2? Can we do the same kind of thing for angle 2? Yep, so I can say the measure of angle 2 plus 38 degrees is equal to 90. Again, it's because the acute angles of right triangle complementary. I'll use less words and then it won't be as weird. Yes, sir. Yes, you have to have the explanations on it. All right, so then the measure of angle 2 is what? 52 degrees. And there we go. All right, so then let's go to angle 3. Do I have enough information to find angle 3? Yes. How would I find angle 3? Ready? Can I subtract it from 90? I don't know that we've had any subtraction postulates or theorems at all, but why? Tell me why you think that. Okay, read. Okay, like this one. Okay. Okay. So what you're trying to get at is 3 and 4 are complementary, but I don't have 4, so that doesn't help me with 3. But all right, Aiden. Angle 1 and angle 2 can be supplementary because what? Okay. Good. Why? Because it's a right angle. I think that's what you were getting at, but you can't just randomly, I'm just going to subtract. It doesn't work that way, right? But the sum of the two angles is 90. So I know that the measure of angle 3 plus the measure of angle 2, which I already found, which is 52 degrees, has to equal 90. Because this plus this equals the whole thing. How do I explain that? Something plus something equals the whole thing. What were those? We had a couple of them already. Angle, what's the rule? Piece plus piece equals the whole thing. So what? Angle addition postulate. Angle addition postulate. Okay. That means that the measure of angle 3 then equals what? 38 degrees. Now, can I say that angle 1 plus angle 4 equals 90? No, because you haven't said that yet, right? If I have to use that, I have to prove that somehow, right? I can find angle 4 pretty easily. You should probably already know what it is, but you still have to set it up. So I can use what Reed was going for here, is that the measure of angle 4 plus the 38 is equal to 90, and that's because the acute angles of a right triangle are complementary. So the measure of angle 4 is 52 degrees. Let's think about what all this means here. These are the same measure. What type of angle pair are these? The three. Alternate interior angles, right? Right? Parallel lines, alternate interior angles. Now, did you know that the lines are parallel to begin with? No. So, I mean, it doesn't say that, so we can't use that, right? But now that they are congruent, I do know for sure that they're parallel. If I'd have had that as a right angle too, I could have. There's ways you could have known that, but that's not what we were going for there. Okay, good. All right, now we have the exterior angle theorem. Exterior angle means on the outside, right? So the measure of an exterior angle of a triangle is equal to blank. Now look at the selfie stick keeps getting away. Look at the 1, 2, and 3. Those are your interior angles. 4 is on the outside. You have more than just one exterior angle, but that's just the only one we're looking at right now. So the measure of an exterior angle, so angle 4 here, is equal to the sum of the measures of its remote interior angles. Remote interior angles. So let's think about what that means. Okay? Why is the remote control to your TV called a remote? No, it's called a remote control because it controls the TV. Why is it called a remote? Because it's away. It's not attached to it, right? Back in the day, the very first remote controls were actually attached. They weren't really remote. They were like attached by a cord or something. When I was growing up, my remote control was my dad laying in front of the TV, arm's length away so he could flip through the channels. He was laying on the floor because, you know, didn't have them back in the day, but actually other people did. We didn't. I didn't grow up with cable either. I was very deprived. But anyway, but remote because it's not touching it. So if this is my exterior angle right here, 3 is attached to it, right? These two are your remote interior angles. The remote interior angles are those two right there. And it changes depending on which exterior angle you're actually using, right? But what this says is that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Now, could you live your whole life not knowing that was true and still get the right answer? Yes, because if you have angle 4, you can find angle 3, because that's what type of angle pair? Linear pair, and then you can figure it out that way. But if this is an expression here and not just a number, probably don't want to go down that road because things may not end up so nicely for you. All right? So let's look at this. We're going to apply the exterior angle theorem. This right here is an exterior angle. Could I find this angle right here? Yes, but I don't care. Okay? Because it says that the exterior angle is equal to the sum of the two remote interior angles here. So I know that 126 has to equal 6x minus 1 plus 5x plus 17. Everybody with me? I can just solve it. So 126 equals 11x plus 16. And I should have put over here. This is the exterior angle theorem. Let's see, 11x plus 16. Which means that 110 is equal to 11x, so x equals 10. Okay? Am I done? No, because it asks me for angle J, so I'm going to make sure that I plug it back into the correct thing here. So this is going to be 5 times 10 plus 17. So the measure of angle J equals what? 67 degrees. Okay? Everybody okay with all that? Any questions? All right, next page. All right, third angle theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles, what do you think has to be true about them? What would make sense? If these two angles here are congruent to these two angles, what would have to be true about the third set? They'd have to be congruent too, right? Because don't both of them have to add up to be 180? So there you go. Congruent. And you need to write up here that there is no third side theorem. Because when we start talking about sides, you're going to say, oh, well, these two sides are congruent to these two sides, so those third sides have to be congruent. Not so. So just make sure you can see the little things here. So what we know here then is that angle N is congruent to angle T. Everybody okay with all that? All right. So, are angles B and E congruent? Yes. Are they labeled that way? No, it actually takes a few steps in a proof, but we know they'd be congruent. So E is congruent, or B is congruent to E, A is congruent to D, so what has to be true about these two? They're congruent. So I know that y squared equals 3y squared minus 72. That I know that because of the third angle theorem. So negative 2y squared equals negative 72. Do I take the square root right here? No, you don't have y by itself yet. So y is equal to 36. I'm sorry, y squared is equal to 36. So what is y equal to? I've got all day. Nope. What's the square root of 36? So you just get one answer. Plus or minus 6. Do they both work when you plug them back in? Yeah, you got two answers, and they both work. Okay, so we know that these two angles here are congruent, so their measures are the same. When I plug back in, whether I plug 6 or negative 6 in, I end up getting the same answer. But the measure of angle C is equal to the measure of angle F, freeze, which is equal to 36 degrees. Now,